Oh, hi everyone. Yeah, so I'm actually at workshops in Germany, so I'm doing this between other meetings as well. But I'd like to talk a little bit about the Skosmos implementation of ELST at CESSDA. So there's a couple of acronyms there if you don't know. ELST stands for European Language Social Science Thesaurus, and CESSDA is the Consortium of European Social Science Data Archives. So now you know, and you will be tested later. Okay. So uh, so what is CESSDA? Okay, CESSDA is a consortium of mostly social science data archives slash repositories across Europe. So we have a really, really good coverage. There are full members and affiliated members, as you can see from the map there. We have pretty much universal coverage across most countries in Europe. And there are a number of reasons for these people to get together, not only networking, knowledge sharing, but there are a specific number of tools that I'll come on to that we produce as CESSDA members. The head office is based in Norway, in Bergen. We refer to it as main office, and they oversee all of the activities of CESSDA. At the moment, there are a number of working groups, and I'm chair of the interoperability working group. So obviously, I have a keen interest in semantic artifacts and semantic catalogs and interoperability. So, just to give an example, we have GASIS in Germany, UK Data Service, who I represent in the UK, SND. So, yes, the main office is the operational hub in Norway and coordinates activities carried out with those service providers or SPs. So there are a number of tools that CESSDA maintains, including the CESSDA data catalog, which is an aggregated catalog for all of the individual service providers. We have the CESSDA vocabulary service, which is a kind of in-house developed service for smaller vocabularies. The main topic that we're interested in today really is the ELST thesaurus, because that's the thing that's implemented on Skosmos. So that is a screenshot of the European Language Social Science Thesaurus. Now, this is hosted on Google Cloud by CESSDA, and it's fully Dockerized, installed on the standard architecture, which is Apache Fuseki. There's a customized front end. I think the customization was relatively straightforward. ELST itself has over, I think it's 3,470 concepts in version 6, so it's quite an extensive thesaurus. Now, a little bit of history. ELST used to be hosted by UK Data Service, and that was on a SQL database with an ASP.NET front end. Frankly, it wasn't a great system, and the fact that it was modeled in a relational database made this incredibly difficult in terms of database consistency. And there were several times where the relationships and the foreign keys got mixed up, and we ended with slight internal corruption on the database. So when Skosmos came along, it was a real blessing because it made it much, much simpler to deploy what is a fairly large thesaurus, out of the box functionality with a Fuseki triple store and a ready-made front end, easy to configure. You do have to make some changes on the configuration files, but it's very straightforward. So now we have a nice, reliable system, which out of the box not only gives you a user interface, but also gives you an API, and allows us to properly resolve URIs. Now, I'm involved with the Onto Portal Alliance, and I think Clément Jonquet, if some of you know, came up with some statistics that 50% of vocabularies have URIs that don't resolve anywhere, which makes them essentially useless for machine actionability. And 80% of systems don't have URIs that provide content negotiation, which basically means using the URI of a concept, you can either get a web page or you can get some useful JSON LD metadata, for instance. So I think in the community, there's still a lot of work to do. But if you don't have lots of in-house resource to do RDF development and data modelers and people who know how to work ontologies, then Skosmos is actually a great kind of out-of-the-box solution for that. So ELST itself, as you can see here, it covers a lot of core social science disciplines, and it currently has, I think, 16 languages in there. We recently added, I think 2 years ago now, we added Hungarian and Icelandic. And we do want to expand that over the next couple of years to other languages. Italian is a possible candidate. There's quite a lot of multilingual coverage there as well. So for anyone who's used Skosmos, you'll be familiar with how clean the interface is. Either an alphabetical list or a hierarchical list. It's really, really easy and pleasant to browse as a system, and that's what we've found over the last 6 or 7 years. Yes, you can see here there's a couple of screenshots of how that works. The hierarchical version is really important for us. ELST has quite a deep hierarchy. I think it goes down to either 12 or 13 levels. So that really clean interface for the browser is really good and important for us. And you can also, I can't remember which version of Skosmos this came along, but a really nice feature is that if you mark up your RDF correctly, so you mark I think we use OWL deprecated as our property in RDF, and then that will automatically render in the display so you can see which concepts have been deprecated and when using I can't remember if it's doubling core modified attributes, but anyway, you get a nice user display. And the important thing is providing that you mark up your data correctly. Skosmos pretty much takes care of this display for you. So it is a really nice system. Okay, so the concept page, as you can see here, we have lots of different translations for ELST. I think I mentioned, Hungarian and Icelandic came across a couple of years ago. The standard Skos stuff comes out of the box, Skos broader, Skos related, history note, unique identifiers. What we tend to do in ELST, we use GUIDs, and I remember some discussions where people were saying, well, these aren't human readable. And my argument is always, well, these are not supposed to be human readable. These are machine actionable identifiers. So in order to ensure they're globally unique, we use GUIDs across the board, as you can see here. Because we work in a DDI XML environment as well, we also include URNs. Which is non-standard, but we include URNs for ELST concepts as well, so that they can be referenced in DDI, which is predominantly an XML specification. So this is all very well. It's really important to reinforce why are we doing this. Now we have 3,500 concepts nearly. They all have unique identifiers, which change over time as well as they're versioned. Now, the reason that we actually do any of this is that our metadata records for our data sets have keywords. And if everyone in CESSDA, and more widely for that matter, uses ELST, then data sets start to become more interoperable and more comparable. So when we talk about harmonizing data, one of the ways in which we can fairly easily harmonize data is to make sure that we're using the same concepts and the same identifiers. So giving you an example here, we have a study called Family Life, Work and Experience. The study number, I think, is 2000, if I remember rightly. But you can see here in the box that I've highlighted, within DDI, which is the de facto metadata schema for social sciences, we have a keyword element. Now, in the old days, we just used to put the keyword is age and the keyword is families. That's useful up to a point, but the fact that we have the identifier in there as well, which is marked as vocab URI within DDI, means that if another repository is using this keyword, we can say quite unambiguously, yes, this is definitively the same keyword, rather than just comparing the strings. We can compare the identifiers. So at a machine actionable level, that opens up a lot more possibilities in terms of comparability and interoperability. So it's the identifiers, for us are not optional. It's really critically important that you include the identifiers in the metadata as well as the label or the term if you want to describe it like that. So with the publishing pipeline, Skosmos is really the publishing platform. And at UK Data Service, we actually use VocBench. And I've heard a number of other people who are using VocBench now, which is a really nice system for editing thesauri and control vocabularies and other ontologies for that matter. We actually host that at UK Data Service. Sorry, I'm on a call. I'm on a conference. No, no. Sorry, just had so I just had someone coming in the door. Yes, so we use VocBench for the editing platform, and we host that on the AWS cloud. Now, within the wider semantic artifact repository ecosystem, there are quite a number of tools that have gained traction over the last 5 years. One of which is obviously Skosmos. We have VocBench. ShowVoc has recently emerged. My personal opinion is that it's still not quite mature enough for a presentation layer. Some of you may have used Web Protege from Stanford as an ontology editing tool. Portal has gained a lot of traction in the last couple of years, both as a semantic artifact repository and a semantic artifact catalog. And they're also, if you can afford it, there are always Top Braid, Enterprise Vocabulary Manager, or Pool Party, but those tend to be more commercial and expensive solutions. But I mean, they are great products if you have the money. The problem is, which we're really kind of feeling now, is there isn't a really nice connected ecosystem where it's easy to create a vocabulary in VocBench, for instance, and have a button that says publish to Skosmos, publish to Portal. And I know there have been some discussions between various parties in the Portal Alliance and the VocBench developers, but I think over the next 2 or 3 years, this would be really nice to see some further progression on this. It's not an easy problem to solve, but it's not a fantastically difficult problem to solve, providing that you have some kind of standard interfaces. One of the outputs that came out of the Fair Impact project was something called Mod API, which was metadata and ontology description API. I think that shows a lot of promise for it being able to interoperate different systems at the semantic artifact level. It doesn't take care of anything, but I think I get the feeling that over time, these interoperability problems are now being addressed. So that'll be really nice to see the development of that over the next 2 or 3 years. The other thing I wanted to mention was versioning as well. Now, there are a number of approaches to versioning. The approach we've taken in ELST is frankly not the most elegant way of doing versioning. What we do is when there is a new version of ELST, we've recently released version 6, for example. We say this is version 6 of the concept scheme as opposed to version 5. Now, what we do is all the underlying concepts then increment a version as well. So we'll say concept X is now version 6, irrespective of whether it has actually changed or not. Now, in an ideal world, a concept URI should be immutable and we should never change it. Which means that in version 6 of a concept scheme, for instance, you might have a mix of concepts which were version 4, version 1, version 6. Now, at machine actionable level, that's not difficult. We took the decision as a compromise, really, to ease this for humans, to make sure that all the concept versions were completely aligned with the concept scheme version. So if you look at version 6 of ELST, then all of the concepts will be version 6, irrespective of whether they've actually changed. What I've put here is that I think there is work to be done on having an industry standard versioning model across semantic artifacts. Whether this is work for a Horizon Europe project or something that should be done through something like Shock Vocab Commons. We did a little bit of work on this last year, and I wrote a few pages on this. It's a difficult area conceptually and technically, but I think there is, this is becoming an issue now in terms of a lack of a standardized versioning model. So one of the things I like to see in Skosmos is maybe a really good, solid, practical reference implementation of how versioning should be done for semantic artifacts. So I mentioned Workbench 3, just so you have a visual fix on this. This is Elst in Workbench. So you can see all the concepts here, which would match what you see in Skosmos. Workbench has a nice hierarchy on the right-hand side. You can see all of the different properties of the concept. So you can see here Skospref label, all of the different translations there. So Workbench, is again was a bit of a blessing because we did all of this in-house in the past. So it would be really nice to see some tighter integration between Workbench and Skosmos, because I know a lot of people are using Workbench now as an editing tool, and Skosmos is a great presentation tool. So a tighter integration between those two would be really good to see. So just a bit more detail about the publishing pipeline for Elst. We manage this in Workbench. You can see here that Workbench has a service layer based on RDF4J. We use GraphDB. We're actually on version 10 now. Actually, this is a slightly older slide, but we use GraphDB as a backend. The dotted line at the top really it just makes it clear that there isn't a clean and automatic integration into Skosmos at the moment. So what we do very crudely is we export the RDF file out of Workbench. We do some cleaning on this, and then we load this up manually into Fuzeki. And then on the right-hand side, you can see that Skosmos presents both a RESTful API for direct calls from machines, but it uses the kind of Sparkle endpoint to render it in the user interface. So one of the nice things is that Skosmos enables the content negotiation to be very straightforward. So if you ask for a particular concept with a particular persistent identifier, you can either ask for RDF XML, Turtle, or JSON LD, depending on your preference. I mean, you would be doing this for software. It's possible, but it's not likely that you would be making manual calls from a Postman is a graphical user interface where you can do that kind of thing. But in the main, the left-hand arrow there is supposed to represent machine calls, and the right-hand arrow is supposed to represent human browsing. So in terms of integrations, one of the things we've done is integrate the CESSDA catalog. You have in Elst a very large number of concepts. And in the CESSDA catalog, I think it's something in the area now of about 40 or 50,000 data sets, which all have keywords. They're not always Elst keywords. But a few years ago, we decided that it'd be a really nice feature to implement if we could navigate back and forth between Elst. So if you clicked on an Elst keyword, that would take you over to the relevant data sets in the CESSDA catalog. If you were looking at a data set in the CESSDA data catalog, you could click on a keyword and go and browse Elst. So this is really an example of how we kind of connect two systems using Skosmos. And the way this works is that providing that you've assigned a keyword correctly to your data set using the URI, as I indicated earlier, then in the user interface, this makes a nice user journey. So if you look in the CESSDA data catalog here, for example, you would see that you have the keywords there, which are Elst keywords. We have one here, which is consumers. And then when you click on that keyword in the browser, that will actually take you through to Elst itself. So you can see here that the keywords in the CESSDA data catalog, trust here is linked to the CESSDA data catalog. Equally, within the CESSDA data catalog, there's something called keyword search. And these are assembled when we prepare the RDF. And I think we use DCAT catalog record as the property to do this. So you can click on a hyperlink, search for trust in CESSDA data catalog, and that will bounce you over to the CDC and will show you all the data sets that have the keyword trust assigned. So that's it's not massively complicated, but in terms of a user journey, this is a really, really nice feature to implement between Skosmos and the CESSDA data catalog. So we have quite a number of languages. Keywords are not just allocated in English, they're allocated in different languages. So that integration, we also have that as a multilingual feature. So if you have a particular keyword in a particular language, you can also navigate on a language specific basis as well. So we always need a meaningless diagram in these kinds of things. So this is just a circle that illustrates very, very simply how concepts and dataset records in the CDC are connected. So another example, which Dance have been working on, is that once we had ELST properly structured, properly rendered as RDF, it opened up the possibility for Dataverse to actually use ELST keywords. Now, I'm actually at the workshop this week with Slava Tikhonov, who did a lot of work on this with Dataverse and for Dance. So basically, in Dataverse now, you can click on a drop-down list of keywords, and that automatically plugs in to the Skosmos instance. So that's a really good example of kind of real-time interoperability that's enabled once you start to structure your metadata in open standards and with persistent identifiers. There's a reference to a paper that Slava wrote on this if you want to follow up, but that's a really interesting example of how you can start to plug systems into each other once you make them properly interoperable. So some of the future developments for ELST that we've got on the roadmap, either for the interoperability working group in CESSDA or more widely in Horizon Europe projects that we're bidding on or are working on, is AI-generated translations. I mentioned Slava's name. If some of you may know that Slava is Ukrainian. So literally this week we've been working on an LLM driven translation module. It uses RAG and knowledge graphs as well. But we've got a system now that can effectively do a pretty good translation into Ukrainian. We need to do some more work on this, but the idea is that for some of the languages where we don't have ready access to translators, we could do a good enough translation for some of those languages. So AI is, I don't know to what extent Skosmos have got AI integrations on their roadmap, and that's for other people to talk about. But certainly, AI assisted translations are a really obvious use case. I think mappings as well. I think for several years we've talked about doing ELST mappings to other vocabularies. This has never really happened, probably due to resource constraints. This is a really obvious kind of use case for AI generated input. One of the standards we would like to see, and we're using kind of onto Portal, is simple standard for ontology mappings. You probably know that in Skos there are a number of predicates you can use, like Skos broader, Skos exact. Now those are fine, but that if you want to be more kind of granular and more subtle about your kind of mappings and relationships, simple standard for ontology mappings is something that's being built into a number of systems, including onto Portal, and we're looking to techniques as to how we can generate mappings from ELST automatically and at scale into other vocabularies and other thesauri. As I mentioned before, we'd like to see tighter integration between editing and publishing tools, which that can include Vocbench, onto Portal, Skosmos. Web Protege possibly, but I know Stanford have got no money at the moment, so that's not likely to be happening. Uh, and they're just as an aside, we have a new social science onto portal coming soon. Now this has actually already been installed, but we need to make some modifications to the code base. But UKDS will be working on that in the next few weeks in conjunction with the onto portal people. This is a semantic artifact catalog rather than a repository. So there will be a copy of ELST on there, but that will be for the purposes of findability and for discovery rather than actually being the repository as such. So these are just a few of the things that are coming up for ELST in the next year. Okay, and I think that is it. Yes, so thank you for your attention.